that is a sinusoidal curve. If this is the parent curve, if f of x is equal to the sine of x, what do we know? We know that this here is 0, 0. We know that this over here is 360, 0. We know that this right here, what is this? What are the coordinates of this point right here? 90, 1, right. Okay. This would be 180, 0. And this is, -1. And we know that. And that tells us that the amplitude is equal to 1, amplitude, and here, that the vertical and horizontal shift is equal to 0, because we didn't move it left or right, we didn't move it up or down. And we know that the vertical and horizontal dilation is also 0. Now comes the fun part. What if we said this is g of x, okay, and that's equal to d plus a sine of bx minus c. Thank you. What did I just do there? Anybody know? Yeah.
It's kind of like the equation that like is going to be like how the graph like looks and add values to it, or how it's going to like change it.
Yeah. I mean, basically what I did was I put in placeholders for all the possible ways to mess up this graph. Right? I got a placeholder here for vertical translation. I have a placeholder here for horizontal translation. I have a placeholder here for vertical dilation, and I have a placeholder here that will affect horizontal dilation, and that will affect two things that are sort of magic words: the period and the frequency. These things are related to each other. The period is the length of time it takes to go through the complete cycle. And on the parent curve, the period is 360 degrees. So how many complete cycles fit into one stretch of 360 degrees? One, right? Yeah, one cycle. If I do a horizontal dilation and I make this do this, and you'll have to forgive me as I try to do this by hand. Okay, so basically, if I've done this, what have I done in terms of horizontal dilation? Yeah.
You compressed it.
Right, I compressed it, factor of 1/2. Okay. What did that do to the period?
Period is 180 now.
Yeah, what did it do in terms of from 360 to 180? What did that do? It cut the period in half, right? I did a dilation of 1/2. It cut the period into 1/2. And what did it do to the frequency? How many fit into what before was only one cycle? 2 cycles. A little lumpy, but 2 cycles nevertheless. Which letter is going to do that? Yeah, P, right. Right? Because it's multiplying the argument inside the function. And what do we know about the way this works? What number does B have to be in order to be able to accomplish this? 2, right? So B has to equal 2 here, which means that 1 over B times the original period is going to give you the new period. So it's the reciprocal of this times the original period that gives you the new period. If B was 1/2, then it would be a stretch, and it would look like this. And then it would go off here, We'd come back at 720, right? This would be only half of the period. The period would then be 720 degrees, because if this was 1/2, I'd have to take the reciprocal of it to multiply that by 360. Okay. Okay, so that's B. What would I have to do to make it go up higher or down lower? Yeah. Right. That would be this one right here. That would be a vertical dilation. Make this go up, down, and up. And then this would do what? Vertical shift, right? And this one, it's a horizontal shift or a phase shift, right? Okay. So this number right here, this distance from here to here, what is that going to be? Yeah. And what number, if I give you this, if I give you that as the equation, which of these numbers is going to be represented here? Right, the absolute value of A. That's going to be the amplitude. If this is 1, then the parent function has an amplitude of 1. If I multiply this by 7, then that's going to stretch this to 7. Yeah.
What if it translates up or down?
What if it translates up or down? Well, basically, you'll notice I'm talking about the distance from here to here, so it doesn't really matter where we are, right? I mean, if this is 600 and this is 607, the amplitude is still 7.
If it's like translated and then there's only 2 on the top and then like 8 on the bottom, it starts to like it peaks at
It goes from where the midline is.
up or down from it.
Wherever the midline is, right? That's where the amplitude is measured from. Now let's talk about the midline. How would I move the midline? Yeah. Vertical shift, and which one of these letters would do that? D. So in fact, this number right here, whatever this is, that's D. Because if there's no D there, if D is 0, then this is the x-axis. If D is -7, then this is -7. If this is -7 and this is 8, then this is going to be y equals 1, right? And this is going to be y equals -15, right? So it's going to look like, oh, wait, this is just 1 up and then 14 down. What am I supposed to do? Well, actually what you do is you count how many there are altogether. Count how many there are altogether. There are 16. Divide that in half. That's 8. So this should be 8 and this should be 8. You know where this is. You know where this is. The midline has to be here. And now it's just a question of counting lines.
Isn't the midline also like just D? Like isn't D the midline as well?
This is it. D,
Yeah.
the midline. Okay. It's also called, just for those of you who like big words, the sinusoidal axis. Okay, we've done this one. We've done this one. Let's talk about what if we wanted this to be 90 degrees? What if we found out, oh wait, this right here, the beginning of the cycle, this is 90 degrees, right? And if you go back another 90 degrees, oh my goodness, it's something else altogether. Yeah, but I'm actually asking you about what if this is the beginning of the cycle, right? In other words, the beginning of the cycle is sort of a misnomer, but normally this point would be 0, 0, right? But I'm looking at it and it's actually 90, 0, which makes this something else, and this something else, and this something else, and this something else. What happened here? Yeah. It's phase shift. Right? So that would make C 90 degrees. This would be C.
No, I was just asking about the period.
And now we're going to do the period.
Oh, I thought we...
Okay? We've done the midline. We've done the amplitude. We talked about the horizontal shift. Right? So now we have this number. We have this number. We have this number. we have this number. What we got to figure out now is from here to here, how much is that? Well, normally it would be 360 degrees. Unless there's been a horizontal compression or stretch. Okay. So 360 divided by the absolute value of b is going to equal the new period. Okay? So Melody, let's say this here was 810 degrees. Okay? This had been 90 degrees. What's my period now? Yeah. So the period now for this thing that we have just drawn is 720. What does that mean b has to be equal to? If this is 720. 1/2, right? Okay, so that means that if I had given you a graph, you'll notice that this goes on and on here. This is a big one. But the lowest point here appears, this is 450 and 900, so this is 90, 180, 270, 360, 450, right? You with me on this? So the distance from, let's say, the top point here, which appears to be 270, there. The distance from the top point here to the top point here is how much? 720. Okay, so that's our period. The period is 720. And if the period is 720, okay, then 720 is equal to 360 over the absolute value of b, and we just did that, right? So that means b is equal to 1/2, right? Now, the high point over here, let's see if we can figure out where that is, or the low point over here. Here. The low point here is at -15, right? And the high point over here, wow, we got to really zoom in, huh? The high point over here at 270, oh, here we go. Can you see the number there is 1? Right? Can you see it? So the minimum, right, in terms of the range, the minimum was -15 and the maximum was 1. So what's the amplitude going to be? Anybody? 8, right? We subtract these, get -16, divide it by 2, take the absolute value. The amplitude is 8. And amplitude is A. Cool. This is working out great. Now, if we want to write this as a sine curve, is there any reason we need to do this as a sine curve as opposed to a cosine curve? Can you tell from looking at this? Is this a sine curve or a cosine curve? Can't tell, really, can you? It's both. Yeah, it could be either one. If you look here at 90 degrees, right? By the way, what's the midline? If you have to count them, you could just count them on a graph, right? No, you tell me. I got -15 down here. I got 1 up here. So I guess 0 would be here, right? And then -5, -10, right? -7, right? Okay. So the midline is -7. What letter is that, by the way? D. Okay. So you notice we have 3 of these letters already, right? How cool is that? What's the only difference between a cosine curve and a sine curve?
Isn't it like where it starts?
Yeah. I'm always uncomfortable using the phrase where it starts, but we all see it that way, right? The parent curve at 0, 0 for a sine is here, right? For cosine, it would be up here, right? So if this is a sine curve, then what kind of shift do we have? Yeah. Well, it's a phase shift 90 degrees to the right, right? And so what letter is that? C. So now where's my equation? My equation was f of x, right? F of x is equal to d plus a times the sine of b times x minus c. Is that right? Okay. And what did we just figure out? F of x is equal to -7, right? Plus 8 times the sine of 1/2 of x minus 90. Is that right? Isn't that what we just did? We just figured that out? All those numbers over here that we did? That's where they go. Well, let's just see. Hey, we're right. Can you rewrite this as a cosine equation without, go ahead. What would you do? Anybody do it? What should it be? Well, let's find out. Let's do it this way. Did the midline change? No, midline wouldn't change, right? So that was -7. Does the amplitude change? No. Okay. Times, where's functions? Functions are here, so I got cosine this time, right? Cosine of, and is my period going to change? No, so this is going to stay 1/2, right? And it's going to be x minus, what's the shift have to be? 270, right? Now, if I did this correctly, then there should be two graphs on here, one blue and one red, that are in exactly the same place. There's the red one. There's the blue one. These two equations are exactly the same. Okay? So, given the drawing, we were able to back up. And if you'll remember, we actually created all those numbers ourselves off the top of our heads just here to start with. Right? This was how we did it going forward. I said, well, yeah, well, what if the amplitude was 8? Then it would be from 8 from here to here. And what if this was 1? Then this would be -15. And this is the drawing we drew. And then I took the same equation using the numbers we figured out for all of these, 8 and -7, right? 8 here and -7 over here, and 720 here, which gave us b is equal to 1/2, and the phase shift of 90 degrees over here.
Yes, this was very helpful, but I just wanted to also make sure that I had all the information correct on the worksheet.
Oh, you mean that particular question?
Yes.
So we're looking at this, is that right? Our maximum is 2, our minimum is -8. What does that mean the range is here, from here to here? What's the distance from here to here? 10. So what's the midline? 5. So D equals 5, right? Wait a minute. 5? -5? Wait, is that really right? -3? So what's 5 then? Okay, so D is equal to -3, but the amplitude is equal to 5. Does that make sense? Well, here's -3. 1, 2, 3. So if this is the midline, then it's 1, 2, 3, 4, 5 up, and 1, 2, 3, 4, 5, 5 down, right? Okay, that worked out. Whew. Now, what else do we need? If this is 10 degrees, and this is where the maximum is here, here's the maximum again over here. What's the period? 60 degrees? Is that what I heard you say? So if the period is 60 degrees, that has to equal 360 over b, right? We agreed on that? So what does b have to be? Okay. And c stands for what? Phase shift. So how much is it being shifted? 10 degrees to the right if what? What kind of curve would this have to be? Cosine. So if it's a cosine curve, it's 10 degrees to the right. Okay, so we'll make that 10, and we'll make the point of having it be a cosine curve. Does it say in the question that they want a sine equation? They say cosine. Oh, how convenient. So then f of x equals -3 plus 5 times cosine 6 times x minus 10. Okay. And there are two ways we could double check. One would be to look in the answer book. The other would be to actually just put the equation in here and see what happened. So now the question is, does this look like our curve? It doesn't too much, or does it? Does that look like our curve? Is this the drawing we had? Okay. So then there you go.